Hi everyone, we're going to pick up with lesson 8A, and our new theme for this is called risk assessment, and we're going to be looking at things that are considered health risks and determining how much of a health risk they are in comparison to not doing them or doing them versus not doing them, depending on the thing. So the first thing that we're going to talk about is that a well-known newspaper once reported that the risk of colorectal cancer is increased by 21% for every 1.7 ounces of daily processed meat consumption. Now, over here they show a lovely picture of bacon, but bacon is not the only processed meat. Processed meat would include ham, bologna, salami, pepperoni, anything like that that's, not just meat without any additives and things. The media often presents the public with information like this, but it can be difficult sometimes to interpret what it means. So when it says that your risk is increased by 21%, we need to know what's the baseline. So if it's increased by 21%, where did that start at? What's your risk without eating the processed meat? Say you never ate processed meat at all, what would your risk factor be then? And so it says, recall that the lesson opening stated, well, it's right here, I don't know why they say recall, that the risk is increased by 21%. What risk measure does this information provide? What does it mean? And right now, I'm going to just say we don't really know that. We haven't really talked about it, and so I'm going to say we don't really know that. We'll come back to that. And so we're going to look at this table. So it says the risk of developing colorectal cancer in a lifetime, just in general, is 1 in 20 for men and 1 in 22 for women. Now, let's talk about that a little bit more. This number is bigger, and so you might think, oh, for females, they have a higher risk. But this is actually a lower risk, because here it says if you take 22 females, one of them is going to develop colorectal cancer on average. Whereas males, you only have to take 20 of them to have one that would develop it. So the males actually have a higher risk. So now it says what percentage of American men. So they want us to write this as a percentage. So 1 in 20 would be 1 out of 20, which remember that bar always means division. So 1 over 20. Remember the symbol means 1, and then the dot is like where the 1 would be on top, divided by, and then the 20 would be the dot on the bottom. It's like a vertical way to write, a horizontal way to write something that was initially always written vertically. Okay, so then if I do that on the calculator, 1 divided by 20 comes out to be, as a decimal, 0.05. And so if we write that as the decimal 0.05, then we can switch that to a percent. We move it over 2 spots, and that's equal to 5%. So there is a 5% chance that as a male you would develop colorectal cancer in your lifetime in general. So what does percent mean? Remember, percent means out of 100. So 1 out of every 20 men means the same thing as 5 out of every 100 men. Those are equivalent to each other. Okay, so the American Cancer Society reported the data about men as a fraction with a numerator of 1. So the 1 in 20. Then we reported the data as a percent. There's other ways to do that. For example, we could make it with a denominator of 100. So if we were going to write that as a fraction, we could write it as a fraction. Remember, 5% means 5 out of 100, so we could write it as a fraction, 5 out of 100. Or we could write it in a sentence as 5 men out of every 100. I like the way my 5s are showing up there. They keep looking like 6s. Just a second. So we could write it as 5 men out of 100 will develop colorectal cancer in their lifetime. So there's different ways to look at it. Here they chose that they wanted to put both of these first numbers in 1. Here, if you could decide that you want the bottom number to be 100. A lot of times they do whatever they think better suits their needs to make it sound better or worse depending on what they're trying to do. The ratios reported by the American Cancer Society are baseline risk factors. And that's without knowing anything specific. So just their gender and that they live in the United States. So then what's the baseline risk for American women? So American women, it's 1 out of 22. So that's not going to come out quite as nice of a percent. If you divide 1 by 22, so 1 divided by 22, you get 0.0454545. So again, remember I do this on the calculator, 1 divided by 22. And this came out to be 0.04545, and it just keeps repeating. Well, of course, I can't write down all those decimals, so I'm going to shift this over 2 spots and then round it. So it's going to be 0, and this is approximately equal, 0.045. And the reason that I don't round this 5 up is because if I round into this 5, this 4 after it says, nope, this isn't big enough to round up to 46, so we're going to leave it 0.045, which would be equal to 4.5%. So the men's risk was 5%. The women's risk is only 4.5%. They're not that far off, but they are. The women's is a little lower. So it says, now imagine that every American male begins eating an additional 1.7 ounces of bacon daily. And they're using bacon as their processed meat. But again, it could be any kind of processed meat. According to the newspaper article, the risk for their cancer then increases by 21%. The current risk is 5%. So what we want to know is what is a 21% increase on our already risk of 5%. So what's 21% of 5%? It's not saying that your risk is going to go from 5 and then just add 21 and increase to 26%. That's not what it's saying. It's saying it's going to increase 21% of the initial 5%. So if you're going to calculate this, this would be 0.21 times 5. We don't have to switch both percentages because our final answer is going to be in a percentage, but we need to switch this one. So what's 0.21 of 5? So 0.21 times 5 is 1.05, and that's percent. So 1.05%. So your risk increases from 5% to 1.05% higher. And so that would mean a total of 6.05% total. So you've gone from a risk of 5 in every 100 men would die from that type of cancer, just in general, to if you look at men that are eating 1.7 ounces of bacon every day, then they increase their risk to 6%, a little over 6%. So the product from question 5 represents the increase in baseline risk caused by eating that additional bacon. Add that increased risk to the original baseline reported. So that's what we already did. That's this number right here. I forgot it was down here. And then it says express this adjusted baseline risk as a natural frequency. In other words, out of 100. So out of 100, that would be 6.05 out of 100. But usually when we do that, we try to make this a whole number. So what we would say is it's about 6 out of 100. So about 6 out of every 100 men that were in that category of eating the extra bacon would develop the type of cancer. Look at the information gathered in the previous question. How many additional men per 100 developed the cancer based on eating more bacon? Well, initially we had 5 in 100, and now we have 6 in 100. So 1 additional per 100. Then it says here, let's go back and see how they worded it. It says the newspaper article reported a 21% increase. That risk measurement is relative risk, since it's that 21% is based off of the existing baseline of 5%. Then in question 5, we calculated the absolute increase. So the relative increase was 21%, but the actual increase is 1% from 5%. Remember, we started at 5% and we went to 6%. So the actual increase is only 1%, but they report it as what they call a relative increase relative to where it started, and they say 21%. So the question is, which one gives you more useful information? Which one communicates the risk most effectively. And I think, and you could disagree with me, but I think that knowing it's going to go from a 5% chance to a 6% chance is more useful. I think the actual risk is more honest or more telling than the 21% risk that they reported, which is the relative risk. So why do they do that? Why do they say there's a 21% increase instead of just saying there's a 1% total increase? And the reason is, honestly, they're trying to scare you into eating better. It isn't that it is bad for you. It does increase your risk, and the American Cancer Society is trying to get you to, eat healthier and live a more fit life. And so the 21% sounds worse than the 1%. So they're trying to get you to eat better. Or be healthier. 21% sounds worse. Yeah, gotta squeeze this in. They are trying to get you to be healthier, and 21% sounds worse than 1%. Remember, the 21% is relative, and the 1% is actual. If you actually add 1% to the 5%, that's where your new risk is at. So our look at risk assessment is going to take another angle, and now we're going to look at what happens when you do something that is considered healthy. So in another article, the same newspaper linked eating white fruits, which is apples and pears, and white vegetables, which would be like cauliflower, would lower your risk of stroke. I think other white fruits, one that comes to mind would be, I think banana is considered a white fruit, because when you peel it open, the inside is white. Same thing with apples and pears. We know apples are typically red or green on the outside, but the inside part is white, so that's considered a white fruit. I can't think off the top of my head of any other white vegetables, but I know we've discussed some in class before. But anything that the fleshy inside part is white. So the information came from a university study in the Netherlands that indicated there's a 9% decrease in the risk of stroke for every 25 grams of daily white fruit and vegetable consumption. So you could eat pears or cauliflower or apples, any of those white fruits, and if it totaled 25 grams, it's supposed to reduce your risk by 9%. So in this case, again, we're looking at what does the news media, how do they present it? How does that help you in making your decisions in what you're going to eat? So the risk measurements appear in relative terms, baseline figures. So let's look at some things that make sense. So it says locate the data given about stroke in the lesson introduction. So 9%. Does this measurement encourage or discourage the consumption of white fruits and vegetables? Well, it would encourage, because it's telling us that it's going to decrease our risk. So answer to that is it's going to encourage because we have a decreased risk. Okay, so as you saw in the previous lesson, relative risks make little sense without a baseline. So here's the baseline for stroke. Now it doesn't split it up by gender, it just says 1 in 6 individuals. So will have a stroke in their lifetime. That's kind of scary. That means if you take any 6 people that are born, one on average out of every 6 is going to have a stroke sometime. So what's the general lifetime risk for a person as a percent, rounded to the nearest tenth? So we're supposed to figure that out as a percent. So that would be 1 out of 6, which remember our calculation for that would be 1 divided by 6. And if you do 1 divided by 6 on your calculator, you're going to get 0.1666. It just keeps repeating. It's not a number that stops. 1/6 is half of 1/3. 1/3 is 0.33333. So 1/6 is 0.33333. 0.1666666. It just keeps going. Okay, the proper way to write that would be 0.16 with a bar over it. But we want to round this to the nearest tenth anyway. Now that's the percent that we round around. So this would be approximately 16 point something. This is where they want us to round it to. So if I'm going to round it, we're going to move it over 2 spots. That puts it here after the 16. And then we want to know, do I leave that 0.6 or should I round that up to 0.7? And the answer is we're going to round it up because we're rounding to this spot. This number to the right of us is going to tell us whether to round up or not, and that's a 6. So that 6 tells this 6 to round up to 7. So in other words, this is closer to 16.6% than it is to it's closer to 16.7% than it is to 16.6%. So we're going to write it as 16.7%. Okay. Hold on. I don't like the way this looks. I'm going to erase this line here. It's distracting. All right. So the next thing, or the final part of this question, it says we want to write that as a natural frequency. So when we see this number, what should we say? 16.7% means what? Well, it means more than 16, but not as many as 17 out of every 100. But it is closer to 17. 16.7 is closer to 17 than it is to 16. So I'm going to write it as 17 out of every 100 individuals. Okay, so apples are a white fruit, and a typical apple weighs 75 grams. Remember, this study was based on 25 grams. So it said that 3 consecutive 9% reductions lead to an overall reduction of almost 25%. Now let me show that. This was in the preview, but if you haven't looked at the preview yet, or it was confusing to you, we are going to go from the original baseline of 16.7%, and every time that we eat 25 grams, in this case that'd be 3 times with 1 apple, it's going to reduce it by 9%. So if I take 16.7% and I multiply that by 0.09, how much is that going to reduce your risk? Well, 16.7 times 0.09 comes out to be about 1.5. It's a little bit more than 1.5, but pretty close. So that's going to decrease your risk by 1.5%. Now, that doesn't happen every time, though, because once you eat your first 25 grams, it brings down your risk, but then that's the risk that you have to look for the next 25 grams. So if I bring this down by 1.5%, that would be 15.2%. I'm just taking 16.7 and subtracting off 1.5%, so I'd give you 15.2. So now I'm going to take that times 9%, because this is what's going to get reduced now. And 15.2 times 0.09 comes out to be about 1.4. It's 1.368, but since we're dealing in tenths, I'm going to say 1.4. So that's a 1.4% decrease. So if I take that off of here, 15.2 minus 1.4 would be 13.8. And then we'll do that one more time for that last 25 grams, because remember, we're doing 75 grams, so that's 25 grams 3 times. So the first 25 grams will give you 1.5% decrease. The next one we base it where we're at now, and that gives us a 1.4 decrease. And so if we take 13.8%, or just 13.8 times 0.09, we get a decrease of 1.2%. So each time it's a smaller number, so we get a little bit less decrease. So now if I take that off of 13.8%, I'm at 12.6%. Okay, so I know this is a little bit hard to keep track of. We've got a lot going on here. But now what they want us to do is they want us to go up and say, what is the relative decrease? If it started at 16.7 and you eat an apple and now you're at 12.6, what's the relative decrease? Well, you went from 16.7% to 12.6%. So you decrease by overall about 4.1%. But they want that written as a relative decrease. So go off of what you started with, the 16.7%, and divide, and that'll give you a relative increase. So if we lost 4.1% of our risk when we originally had 16.7%, what is that as a relative decrease? So 4.1 divided by 16.7. I'm just doing this on my calculator. I get about 0.25. And that's where they're getting that 25% from. It's like 2.45555. We could even say 0.25245 if we wanted to. I'm just going to stick with 25%. So it was about a 25% decrease, which is the number that's where they were getting this number from. So this is relative. 25% decrease is relative. This is the actual decrease. So the actual decrease is 4.1%, but the relative decrease compared to where it started is 25%. So now it says think about a general population of people who eat an apple a day, but would otherwise have a general lifetime risk of stroke of 1 in 6. Given the information, what is the decrease in lifetime risk for this population? So that would be the 4.1% that we already calculated. Kind of got a little ahead of myself. Think about your answers. Which one, or what is the approximate lifetime risk for those if they eat an apple? They call them the population of apple eaters. What would we write this as a natural number? Would we 12.6% would be, we'd actually have to say 13 if we're going to write it as a whole number. So now we went from 17 individuals out of 100 on average having stroke to 13 out of 100. So about how many fewer in every 100 suffer a stroke? Well, that's that 4.1%. So about from 17 to 13, it's about 4 in every 100 people less. So that's actually eating an apple. The relative benefit to that is higher than the relative risk that we have for colorectal cancer with the bacon. Now these are two different illnesses. This is stroke and that was for a type of cancer. But still for this particular situation, this is a better increase than the other was decrease. So our new table that we're looking at here is and this is, we're still on lesson 8B, we're finishing up 8B, is a table showing men and women and normal blood pressure versus hypertension, which is high blood pressure. So this is their risk for stroke at the age of 65. So their risk of having a stroke, if they've made it to age 65, men with normal blood pressure have a 10% chance that they're going to have a stroke sometime in the rest of their life. Men with high blood pressure will have a 20% risk. Women will have a 14.6 if they have normal blood pressure and a 25.8 if they have high blood pressure. So now it says they want us to take this and convert the values in the previous table to natural frequencies of 1,000 individuals. So this one, for instance, 10.4%, they switched to 104 out of 1,000. So let me show you how they did that. I'll do it with this one and then we'll do it with the remaining ones. So 10.4%, remember, means 10.4 out of 100. Well, if I don't want this as a decimal and I don't want to round it, it says let's do it out of 1,000 instead of 100. So they switched it to 104 out of 1,000. They just shifted both the decimals. Move this over 1, move this over 1, and this is equivalent. So 104 out of 1,000. So this, and I know you can probably do that in your head, but let's do it the same process again just so we don't confuse anybody. So that would be 20.5 out of 100, which is equivalent to 205 out of 1,000. So here, this would be 2 out of 205 in 1,000. I can't write as small as they need me to. And then for women, the 14.6 would be 146 out of 1,000. And the 25.8 would be 258 out of 1,000. Next, we're supposed to complete the table of estimates for the population of individuals who regularly eat an apple a day. Report each risk measurement as a natural frequency. So here we have the men with normal blood pressure. If you recall, the percentage decrease for eating an apple was a 25% decrease. So let's investigate where they got this 78 from the 104. So right here's, we were going from this number to this number. And how did they do that? Well, it was a 25% risk. So if you take 104, I'll put it over on this side. So if you take 104 and you try to decrease that by 25%, we'd need to take 104 times 0.25. And that would give us a little bit more than 25% because it's a little bit more than 100. So then what we get is we actually get 26. So it is going to decrease it by 26 individuals. So we're now going to take 104. We're going to subtract 26, and that's where they get the 78. So decreasing 104 by 25% decreases it by 26 people, so it takes it from 104 to 78. So now let's do the same thing for the women with normal blood pressure. It was at 146, and we want to decrease it by 25%. So what's 25% of 146? And that comes out to be 36.5. So now I have a decision. I want to write it as a natural number out of 1,000. So if it's 36.5, do I treat that as 36 or 37? Well, since this is 0.5, that's going to tell us to round that 6 up to a 7. So we're going to say approximately 37, and we're going to take our original 146, and we're going to decrease it by 37. So that would give us 109 in 1,000, or out of 1,000. Okay, so now we have to do the same thing with the people that are in the high blood pressure category, the hypertension category. So if we go up here to 205, if we want to decrease that, I need to take 205 times 0.25, and that'll give us, should be a little bit more than 50 because it's a little bit more than 200. So that should get us about 51. It's 51.25, but we'll just say approximately 51. And if I take the 51 and I subtract it from the 205 that was there before, I get a total of 154. So this is 154 in 1,000. Oh, my 5s keep looking like 6s. Let me see if I can fix that on that. That's supposed to be a 5. 154 out of every 1,000. There, it looks a little better. All right, so then on the women with hypertension, we would, instead of having 258 in 1,000 that would be likely to have stroke, we're going to take the 258 that was there originally. We're going to take that times 0.25. That's going to get us about, it's 64.5. So I'll write that down. It's 64.5, but we'll treat that like 65 because 64.5 is considered closer to 65 than 64. So I'm going to decrease this 258 by 65. So 258 minus 65, and then we put that total of 193 up here. So this is 193. Let me try that again. So that comes out to be 193. And we write that up here. So 193 in 1,000. So now we just want us to analyze this a little bit and answer some questions. It says, look carefully at the categories. Write a sentence making at least one comparison within one table, and write a sentence making at least one comparison between the tables. So we could look at either table. I'm just going to look at this one. And if we look at these numbers, something that kind of pops out at me is the fact that the men here with normal blood pressure are at 104, and then the hypertension is at 205. Same thing over here, 10.4% to 20.5%. So what I might say here is that men with hypertension are almost twice as likely to have a stroke. Say 65-year-old men, because that's what this table's for, are almost twice as likely to have a stroke in the rest of their lifetime. Not at the age of 65, but these are people that are already at the age of 65, and we're assessing their risk of having this stroke sometime between now and when they pass away. So for part B, it says we're supposed to write a sentence comparing the two tables. So is there anything that stands out here between the two tables? And one of the things is we can go back and kind of look at these numbers. The 104 got us 26, 146 got us 36.5 or 37. This number we decreased by 51, and this number we decreased by 65. So one thing, again, you may notice something different, and it's perfectly fine. They just want us to comment on something. So one thing that I noticed is that the biggest number got the biggest gains. So we were able to have 65 less people in 1,000 that didn't have a stroke by eating an apple. So the risk group of hypertension women gained the most from eating the apple. Now, that doesn't mean it's not 25%. It's just that they started bigger. So a 25% decrease on 258 is more than a 25% decrease on 104. Since it's a bigger number, if I take a percentage of it, I'm going to take it's going to give us a larger percentage. So we were able to, let me go back and circle these, maybe change this to red. So for here, remember, when we started with 104, we had 26 additional people that did not have a stroke, or 26 less people that had a stroke. Here, when we started at 146, we had 37 people less that were going to have a stroke. Here we had 51 less people having a stroke. But in this highest category, we had 65. So the bigger the number got, the more people we were able to help with that apple a day. So I'm going to pause now, and we'll pick back up here in a minute with 8C. So continuing with our theme of risk assessment in Lesson 8C, we're going to talk about different risks for two different groups, and we're going to talk about a medication that's supposed to reduce heart attacks. So it starts out with that many drugs are designed to reduce the risk of a disease or to reduce the severity. So a new drug is advertising that it reduces the risk of heart attack by 50%. So at first glance, and we don't have to analyze it yet, that's what we're going to do, but at first glance, do you think this is an effective or good drug? Well, if you have, you have a risk of heart attack and somebody said they could cut that risk in half, you'd probably think that was pretty good. And, so maybe your doctor would agree. So it seems at first glance that, the answer is yes, 50% decrease is great. So let's analyze that and look at it for different groups. So this group 1, this was a study, or this is a group of individuals that lived in Africa, And this first group are 40 years old. They do not have diabetes. They do smoke. They do have high cholesterol, and they do have high blood pressure. So, this is a good thing. Let me mark this. This is a good thing. The 40 is just the age group, so that's kind of neither good nor bad. But these would be considered, risk factors. Smokes, high cholesterol, high blood pressure. So over here, what are some things that group 2 has? Well, they also have high blood pressure, but they have low cholesterol and they do not smoke. So if we go and we mark up the other side like we did that side, do not have diabetes, that's a good thing. Do not smoke, that's a good thing. Have low cholesterol, that's a good thing. But they do have high blood pressure. They're both 40 years old, so we'll just kind of leave that as a wash. The World Health Organization, or the WHO, reports that individuals in Group 1 have a greater than 40% risk of suffering a heart attack within 10 years. The same report indicates that individuals in the second group have less than 10%. And so that's what we're going to be working off of. Our first question here says, what are the differences between the groups? So we already marked that up. So I'll just put a thing here. We marked it. So the differences are that this group, even though both groups have high blood pressure and are 40, this group has 2 more risk factors with their high cholesterol and their smoking. But neither group has diabetes. So if 500 people, in the original directions it says to split this up amongst different groups in the class, but since we're doing this all together, that's kind of a moot point. So it says if 500 people from your assigned group, we're just going to do it for both groups, are observed for 10 years, how many individuals would you expect to suffer a heart attack? So let's break this down. So for group 1, it says that group 1 has a greater than 40% chance. So that's 40% of 500. So 40% of 500 would be 0.4 times 500. Remember, of almost always means times in math. Not always, but almost always. So if I take 0.4 times 500, that's going to give us 200 people. So for group 1, out of 500 people, they would expect 200 of them to have a heart attack in the next 10 years. That's what it said over here, within the next 10 years. That's a lot of people. So now let's do the same thing for group 2. So for group 2, it says they have less than 10%, so we don't know how much less, so we'll just use 10%. So 10% of 500, same size group, which would be 0.1 times 500, which we learned a while back that if we want to do 10%, we can just shift a decimal over. This comes out to be 50. So the first group has 200, and the second group has 500. So this was group 2, this was group 1. If 500 people from your assigned group are treated with the new drug and observed for 10 years, how many individuals would you expect to suffer a heart attack? Well, remember that the drug was supposed to reduce it by 50%. So if group 1 was supposed to have 200 people that would have a heart attack, if that entire group took the new drug, you would expect in group 1 to have half as many people. So group 1 would be only 100 people, and group 2 would be only 25 people. So group 1, group 2, and this is with the new drug. Okay, so with the new drug, this is what we're getting for numbers. Then it says to create a bar graph, and I didn't like the way this bar graph was set up, so I changed it. Instead of saying heart attacks, no heart attacks, I have group number 1 and group number 2, and we're going to graph this like this. So if we have group number 1 and we want to mark how many are going to have heart attacks without the drug, that would be 200. So I'll make a little bar here. And if I was doing this regular, I might color that in, but it'll look pretty bad with this pen. So, and then group without the drug, there's only 100. So you can visually see, if I try to keep these the same width, that cuts our risk in half. Now let's go to the other group. And this group has, for group number 2, with the drug, remember we had 50 people. Try to keep the same width here. And without the drug, we had 25%, or 25 people rather. So why does there seem to be such a dramatic difference? I mean, if both groups were cut in half, then why does this one look like it's so much better than this one does? Well, the answer is this group had more risk to begin with, kind of like we had in the last section. You know, the more people you have in the category, the more the 25% is going to reduce it. Same thing here. If you have 200 people that are going to have a heart attack and you cut that in half, that's 100 less people having a heart attack. Whereas with this group, if you have only, and I don't mean that lightly, but if you have only 50 people that are going to have a heart attack and they take the drug, then they're going to only reduce to 25. So you're cutting it in half, yes, but you're only reducing your number of people by 25, whereas here you're reducing it by 50. So let me write something. Okay, so it's going down 100, but it's still 50%. With this other one, it only went down by 25, but that's also 50%. So now it says you're planning to publish this report in a health blog to advise people. Write a few sentences to accompany that. So if we wanted to write something about this, what they're getting at is saying something like, this new medication reduces the risk of heart attack by 50%, which can the idea I have in my head is that it can most significantly help those with a high risk. So this group that had a high risk was potentially helped more than this group because they already were at a bad place. So that's what they're talking about, just kind of summarizing what was there. So for the rest of Lesson 8, we're going to still keep talking about this risk assessment. In fact, we're going to talk about this same new drug from the last unit. And if you recall, that drug reduced the risk of heart attack by 50%. So it says, suppose a group of people have a 0.5% chance of suffering a heart attack. How do you think the absolute and relative changes in the number of individuals who are expected to suffer will compare? So remember, for group 1, we had 200, which went down to 100. So our relative change was down 100, but that was 50%. Then for group 2, we were at 50 to start with because they had a lot less risk factors out of 100, which went down to 25 out of 100. Still 50%. So here, if we have this group, still 500 people, and they have a 0.5% chance, what is 0.5% of 500? So let's write that down. So 0.5% of 500. Well, when we switch this to a decimal, we're supposed to go back 2 spots. 0.5% is small. It's not even 1%. So this comes out to be, if I shift this decimal over 2 spots, 0.005 as a decimal. I like to put the 0 in front, but it's not necessary. I think it's just easier to see that there's a decimal there when you do that. So 0.005 times 500, and that comes out to be 2.5. So if you do 0.005 times 500, you get 2.5. So even, if we rounded this up even, worst case scenario, and said that that's about 3, you would expect 3 out of, or 3 in, out of every 500. So now, if this group takes the drug, if all these 500 people take the drug, what's that going to change the risk to? Well, it's kind of hard to cut these numbers in half because they're not even whole numbers, let alone even numbers. But half of 1.5 or of 3 would be about 1.5. So we could say 1 or 2 out of 500. Being a little flaky there. It's actually 1.5, but then we would have to round that up to 2. So the absolute change is we went down by about 1 or 2 people. Depending on if you decide you want to round that to 1 or 2. Should technically be rounded to 2. The relative change, though, again, is 50%. We went from what we had, and the drug cut the number of people who had a heart attack by 50%, cut it in half. So it says, based on your calculations, critique the statement, a drug which reduces the risk of heart attack by 50% will most likely save many lives. Well, of course, it can help save many lives, but it's probably best used with those groups that already have a real high risk. So especially in high risk groups. Okay, those people who have a lot of risks for a heart attack. So what information would you like to know? Oh, sorry, I forgot to read this up here. So it says drugs can help people lead healthier, more comfortable, longer lives, but they can also harm people. All drugs have side effects, so it's important to consider carefully before deciding to take a medication. So here's the situation. Lipitor is a drug that's prescribed to reduce the risk of heart attack. Works because it's a cholesterol reducer. High cholesterol is believed to increase the risk of heart attack. So the company that makes Lipitor published the following. It said, and you might have heard this on a commercial, along with diet, Lipitor has been shown to lower bad cholesterol 39% to 60%. Okay, so not bad. If your cholesterol is, say, I'm not even sure for just the bad cholesterol, what's the cutoff? I think 300 is considered high cholesterol if you're above 300. So say you have a cholesterol level of 400. Well, 39% to 60%, if we're looking at that, so you have 400, then if it reduces it by 39%, that's going to reduce it by 156 points, which is now 244. But it's got a range here, so what's 60%? So if you were at 400 and you reduced it 60%, that would reduce 40 times, sorry, I can't talk. 60% of 400 is 240. And so if you do that, you're down to 160. So according to this, if you had a bad cholesterol of 400, taking this medication would take it down to somewhere between 244 and 160. If 300 is the cutoff range, then that gets you into the good area in both of those. But what information would you want to know if you were considering taking Lipitor? And it's the same thing up here. Is it valid for these people in this risk group to be taking a medication? You know, if you only have a risk of 3 out of 500 risk of having a heart attack, are the side effects and those types of things of the drug worth it to reduce that risk to 1 or 2 in 500. So what would you want to know if you were going to take Lipitor? So some of the things that I've talked about with classes in the past. How high is my cholesterol? How high is my bad cholesterol? Because just because it's good for a group that has high cholesterol, does that mean that it's warranted for you? Do you even have bad cholesterol? How bad is it? Also, you know, always a factor, how much does it cost? Hold on, I was starting to write money, but that doesn't. Okay, so cost. And also, what will the insurance pay? So will your insurance cover this medication? Also, what are the side effects? Is there something irritating or frustrating or potentially dangerous to taking Lipitor? Are there side effects? And so all of those things are going to be things that you're going to probably want to know before you agree to taking Lipitor. Also, you may ask, how long do you have to take it? Is this a lifetime thing, or is this, oh, I take this for a couple months, it lowers it, and then I'm done? Which is not typically how statins work, but all these things, just as far as a medication in general, if they're saying, oh, you need to take a medication for your asthma. Okay, well, you know, how do you know I have asthma? What things could happen if I don't take this medication? Well, if your insurance won't cover it, is there another medication that you can take? So lots of things to consider when considering starting a medication, if it's a long-term, which cholesterol medicine typically is. So hope this helped everybody. Don't hesitate to go back and watch through these videos as you're reviewing for your test. And best of luck to everyone, and I will be back after the test with Lesson 9, with Unit 9, Lesson 9A.